So it gives me pleasure now to give the floor to Roslesinforg company. You know that we have people making software or hardware. For those of you who don't know, Roslesinforg is one of the most powerful entities in Russia that uses geospatial data with the branches across Russia. And these guys are not bashful kind, you know, they are hard to surprise. Mr. Arkhipov, Deputy General Director, will make a presentation.
Distinguished colleagues, it is well known that Russia is the largest wooded country in the world. It is also well known that as a result of market reforms, all forest business is privately owned. But forests, as they used to be federal property during Soviet times, same way at the moment, they remain to be a federal state property, which means that the main responsibility for the information support of the forestry activities is borne by the state. And that's why we are having difficulties. This particular issue was discussed at a special state council organized by in Ulan-Ude by our president. And that's where a statement about a very difficult situation with information support of forestry was made. And it was one of the reasons behind this, quoted, the low pace of the forestry business rate and with its lower investment attractiveness. And at that state council, they have formulated a direct instruction to executive committees of the state authorities responsible for forestry business to undertake measures to ensure a more systemic forestry and forest organization in especially intensive forest use zones. This is quite a tough, challenging task, but at the same time it's very inspiring and exciting. Understanding that based on the overall idea that in the zones where the forests account for 250 and more million hectares, you understand the sheer scale of this task given down by the president. So what are the prospects of emerging victorious in implementing this task? To do it properly, it is quite cost intensive to hope for systemic funding, understanding the overall area, and so we cannot count on real federal money support. At the same time, as the experience of developed wooded countries show, the remote sensing method for forest classification helps us get good products which would satisfy the needs of the state and at the same time perform the information support function throughout the whole of forest product chain, delivery chain. Understanding this new vector of forestry activities, understanding our market prospects, starting from last year, our company has been organizing and developing a large innovative theme under the branding of From Imaging to a Project. I must tell you that we borrowed the style and branding approach of our friends from Records, because we want to cover the whole delivery chain in our project, starting from aerial photography, which are quite difficult to arrange in Russia, until the personnel development. And the functional link of this chain is the Visual Map A3 technology plus PhotoMod plus the software complex SOL. And Dmitry Mikhailovich is going to continue. He is the main person behind this. May I continue, dear colleagues? I will try not to infringe on the time of coffee break. The project consists of 5 components: the actual development of the technological map of the project, from imaging to the project, and improvement of the interpretation method for forest classification by applying modern software and hardware. Additionally, we developed a special module of photomod stereo measure jointly with the records company, development of a software suite for information analytical support for forest planning called YESAUL, and the development and improvement of training programs for personnel development. The main goal of the project in general is to improve the productivity and efficiency of the works on forest classification. The main task is to develop the technological cycle, choose the most optimum software-hardware combination, test running it on the actual pilot project, preparation of specialists, and then economic evaluation. In general, the technological cycle from imaging to project includes 3 components: aerial imaging using Vision Map A3, then interpretation using photomod software, and GIS development using the software YESAUL. These are the generalized characteristics of the photogrammetric complex visual map A3, the specialized operator's place for the interpreter, the stereo monitor for the interpretation, and the means for stereo interpretation, and the complex software suite YESAUL. The flowchart shows that we have on the parallel 2 flows: imaging, processing of remote sensing data for deciphering or interpretation, for orthophotos, for stereo pairs, preparation of the polygons, personnel development and training, and analysis of the interpretation features for cameral work to identify or extract features of forest based on the aerial photography images. And simultaneously we will build the map base. Then massive work on contouring and analytical interpretation, generation of information, geoinformational database, and delivery of results. Here in the table form, you can see all these stages in greater detail. You can see their contents, the applied software. Again, that would be the means which are interlinked with visual map and some of the applications and software, and photomod, ArcGIS, ArcGIS program, and the software suite YESAUL. And the final results in the last column. I'm not going to go into detail there. I'll skip that. The main outputs expected from us by customers: standard materials on forest classification, a full set of documents with the classification descriptions, taxographic materials, maps, plans of wood planting, and perhaps other types of materials if the customer wishes so, like photo plans, for instance. This theme is not unique for us, is not first project for us. I showed you a number of bibliographies, the authors who were working on the application of photogrammetric methods to get forest classification characteristics. That includes both Russian specialists along with a photomod company about 10 years ago, also specialists from Croatia who at the moment have issued a number of publications. Also Belarusian specialists are listed here. Next direction is studying the capacities of the modern materials of remote sensing, data acquisition of aerial space imagery for forest classification. Here you can see a quote what the interpretation method for forest classification is all about, and what are the main indicators extracted and detected here. We had an experience of the first flyover using the camera A3, and we had an experience of identifying the main principal indicator for us, the tree heights. We had some misunderstanding originally, but as a result of this test flight, we invited 10 executing possible contractors who studied also the heights of trees, and we measured them in our flyover. And you can see that RPC rate can be different, of course, but it still lies within the expected 15%. This slide shows the results of the assessment of possible use of stereo imaging using GOI-1 sensor. We had 6 model polygons here in 6 different regions of both European and Asian parts of Russia, and here you can see reflected the numbers, the errors of interpretation of the main taxation indicators in regions by comparing them with the actual field verification. In overall, the results are quite optimistic, although they can vary. This slide shows at the moment the requirement for accuracy of expected results after interpretation. This is the second column here, and the last column shows the expected results, which we intend to acquire applying the means of our technology. So far, this is an ongoing process. Our specialists are still working in the field on model or pilot sites, and here we see the projected numbers, of course. The selection of software. On the right, you can see the selection criteria which we need to meet as foresters, the possibility for stereo vectorization, stereo visualization, using different colors to differentiate coniferous trees from broadleaf trees. Here we see a list of quite popular software products, and the red color highlights the ones which met our specs in the first approximation. The second approximation, we went for photomod, stereo draw to be exact, which can be easily applied for mass production, but it must be improved. At the moment, we have a joint project between Roslesinforg and Rakurs company to develop a less cost-intensive and more useful module, which will be called photomod stereo measure. Among the tasks related to the improvement of some of our tools that we require for vectorization, it includes also adaptation of materials of Visual Map A3 for the needs of forest stereo interpretation, and additional wishes on vectorization and development of attributes. Our product of Roslesinforg, the software to form the final geoinformation system, which is called YesAul Suite. We use it for an integrated analysis of forested areas and formation of geospatial data banks for forest registry accounts and for rapid access to users using web services, information protection, and other tasks are performed by this suite. The conceptual scheme of our suite, called YesAul, the place of YesAul suite in the technological process from imaging to the project, storing of attribute data and spatial data on the server, organization of 4 different working spaces with the specifically listed software here. Surveyor, land surveyor, taxator, and interpreters and cartographers or mappers. You can see these pilot sites that our specialists are working in the Leningrad region. We used A3 for image acquisition. The characterization of these sites, typical for northwestern part of Russia, the overall list of works, how to work on those test sites, and the last part of the project is preparation or training of our specialists. Will analyze the existing training programs and curricula on remote sensing data, and we will verify, or rather study the existing remote sensing data and look at the previous experience of training specialists and try to meet the needs of our from imaging to project motto. Here we look at different levels of computer skills and so on and so forth. The expected advantages in forest classification using this technological cycle: meeting the accuracy requirements, reduction of the overall costs of this work compared to field work of taxation. The main goal was mentioned by Vladimir Ivanovich, that as a result of the development of this project, we'll be able to ensure the readiness of the company to implement the federal program on periodical taxation of forests in the amount of 20-30 million hectares per year. Remembering the report made by Roscartography representative, we are in the trend. We are also experiencing difficulties with funding, problems with the qualified personnel, and technologies are in shortage, and here we can show you the example of how we can possibly resolve this difficulty, and we're counting on positive feedback. Thank you very much. Thank you, Dmitry. This is how production people are working. They speak very fast, but very to the point. Although, what can you sell in a place where Reisman already made a presentation? Okay, your question then.
We
come from Roscartography. I have the following question. I looked at your table. There you show 0.5 meter resolution imaging. Have you analyzed what you need to use for that? I understand about airplane, but it can be done locally somewhere. But with our sheer size of forest, you won't be able to resolve this problem with airplanes. You will have to use high-resolution space imagery for that. You showed also a big selection of different software that you use. Of course, that it's good that you have selected photo mod, but what I can warn you against is that if you select too many programs, software at the same time, you can have problems with their compatibility. Does mean that also another part of question, do you take some existing maps as a foundation and then you overlay your data? Well, as our foundation is the imaging, then as a result we develop maps, and so you don't use maps as a basis. You said use orthophotos. You mentioned, as long as, unfortunately, we are limited in our capacity, when developing digital basis, we use cadastral maps to know where a forest is ours, where it's not ours, but still we try to rely mostly on aerial photography. Speaking about satellite imagery, so far we are not sure about this. Under this project, we rely mostly on aerial photography. In the presentation, you saw the results of GUI, stereo imaging, which is quite comparable with the required results. 0.5 meter is good, and 0.3 and 0.12. Maybe it's even too good for us. So far, we have no final answer to that. Hopefully, you are satisfied. My question is about forest classification. Here, classification means the identification of boundaries of forest, also the different diseases of forests. Unfortunately, the main thing for us is measurement taxation. We'll look at some indicators as such thing as height of trees. So we identify the varieties of trees and the overall stock of trees. Some of the clear malfunctions or malformations trees can be identified, but not all of them. Do you have methodologies of this detection, or this is a future prospect for us? This is a future prospect for us. In the past, when the remote sensing data in the 1960s and 80s were used also for detection of damages of the forest based on the satellite images of that period. So we had some positive experience accumulated since then on how to detect forest fires and windfalls and so on. But it's not clear whether we can use it with digital materials. Okay, good. If you have more questions, you'll ask them during the break. That was perfect. Thank you very much.